So these are the pre-lab questions, and three characteristics of a strong electromagnet are a thick wire. The thicker the wire, the lesser the resistance, and the greater the flow of the current. The number of coils, the greater the number of coils, the stronger the electromagnet, and a high voltage power source. So like the battery. And the thickness of the wire will affect the strength of the electromagnet, in that the thicker the wire, the stronger the electromagnet will be because there's less resistance. And for number 3, since the iron nail is a ferromagnetic substance, in the presence of a magnetic field, its magnetic domains will align, contributing to the overall magnetism. So this is the electromagnet that I made. The inside, the core, is the iron nail, and this is the insulated wire, the coated insulated wire with the copper, and we're gonna see if it can pick up the paper clip. So since this side is repelling the north arrow of the compass, that means this is the North Pole. And since this side it lands on north, it's the South Pole. To quantify the strength of my magnet at home would simply to be how many paper clips it can pick up. So the more the paper clips, the stronger it is. And the pointed end of my magnet is the North Pole. And I found out by using the compass. To reverse the poles of the magnet, I would simply switch the ends of the wires, and switching the ends that touch the positive side and the negative side of the battery. And here's my diagram of the magnet and the flow of the current. So south is labeled with S, and north is labeled with N, and the arrows are pointing in the direction of the current, with the positive and negative labeled of the battery. And my electromagnet, as shown before, can already pick up paper clips. 3 things to make my magnet stronger. I could just apply all of the characteristics of a strong electromagnet from the pre-lab question. So I could have a stronger battery, or just add another battery. Increase the thickness of my wires, so that would decrease the resistance, and add more coils. In conclusion, this lab allowed me to actually build an electromagnet instead of watching simulations. And by obtaining the necessary elements and having to construct it myself, I could see how it works and how the various components interacted. The core, which was the iron nail, the power source, which was the battery, and the wire. I also was able to experiment with the various factors that contribute to a strong magnet by trial and error. For instance, in the beginning, since my nail wasn't long enough, I wasn't able to have enough coils, so it was too weak to pick up even a paper clip. And using the compass, I was able to see how the North Pole repelled the north arrow and how the South Pole of the nail attracted it. I also saw that the current flowed from the positive end to the negative end of the battery.